Okay, homework problem, regular physics, UT Quest projectile motion full parabola. And this problem, we're given a thrown stone and we need to compute something a little bit different, the launch angle. What we're given here is we're given that the stone is thrown at a certain initial velocity, and then we see that the stone slows down as it reaches its highest point. In this case, it slows down from 76 to 58 meters per second. And when we think back to our discussion of projectile motion, it's logical that the velocity slows down as the stone rises, but we were taught that at the apex, that velocity is supposed to become zero. And here it says it reaches highest point, it's 58 meters per second instead of zero. So let's take a look at what's going on here. And I'm going to do a little sketch of the situation. There's our initial velocity. We've got our parabolic motion, and there we are at the apex. Now what we have here is we have a 76 meters per second right at launch, and at the apex we have a 58 meter per second. Now, this problem is actually kind of clever, and that in order to solve it, we really need to look at the two-dimensional nature of our velocity in parabolic motion. Now, our 76 initial is a purely two-dimensional initial velocity. So that 76, it has an x component and it has a y component. Now, when we get up to the apex, the y velocity has decreased to zero. So we've kind of stripped away the y component. All we're left with is this x component of 58 meters per second. Now we know from our study of parabolic motion that 58 meters per second is a constant. The x component will never change. So that means if I had a 58 meter per second in the x direction at the apex, that also means I had a 58 meter per second x direction velocity at the launch point. All right, so now what I have when I look at my components, I have my right triangle, I have my hypotenuse of 76, have a side adjacent of 58. So I can set up my ratio, my equation, use the arc sine of the ratio, and calculate the launch angle theta. So again, kind of a clever problem that incorporates really the two-dimensional nature of velocity and parabolic motion.